Our next unit for pre-calc is still sticking with trig functions. This time we're going to learn how to simplify trig expressions. So in order to do that, there are several trig identities that we need to remember or learn about. So if you look at the first set of our trig identities, these are the reciprocal identities. You know all of these, you worked with them quite a bit in Unit 4, so I'm not going to go through each of them individually. Our next set of identities you are also familiar with. These are the quotient identities with tangent and cotangent, and you know those ratios as well. The ones that are new to you, at the bottom of the page here, we've got the Pythagorean identities. So there's different ways to look at how trig functions relate to one another on the unit circle. I'm going to run through showing you how the first Pythagorean identity works, and the other two can be generated in a similar manner. So I'm going to ask that you trust me that they're also true. So our first one, we've got sine squared plus cosine squared equals 1. So if we have an angle of rotation on the unit circle, so here's a point out here on the unit circle, here's our theta, our angle of rotation. Remember, the ordered pair is cosine of theta is your x value, so that's the horizontal distance from the origin. And the y value is sine of theta, so that's the vertical distance from the x-axis up to that point. It's also a unit circle, so the hypotenuse is 1. So if you look at setting up the Pythagorean theorem for this right triangle, you would have cosine squared of theta plus sine squared of theta equals 1, or 1 squared. Again, as I mentioned, the other two can be generated in a similar manner. What we're going to do is verify trig identities. So our examples are going to be an equation where the expression on each side of the equal sign looks different, and we have to simplify one side of the equal sign so that it matches the other side of the equal sign. Here we've got some different steps that you can take to verify trig identities. First, you want to work on one side of the equal sign only. Pick the side of the equal sign that has the more complex expression and get it into its simpler form, which will, like I said, match the other side of the equal sign. You want to use those trig identities. The Pythagorean identities are really common, so make sure you're familiar with those. If you have a fraction, you can split it up. Tomorrow we're going to learn how to factor, and on the third day we'll learn how to add fractions, so we'll look at those later. And another one that's really helpful is number 5. Keep that in mind. Convert to all sine or cosine, and typically you're going to get something to cancel or simplify out. Starting off with our first example, on the left-hand side we have 2 trig functions, and on the right-hand side we only have 1. So the left-hand side is the more complex side of the equation, so we're going to simplify that. I'm looking at this and thinking I could convert to sines and cosines and get something to cancel. Secant is the reciprocal of cosine, so we've got 1 over cosine of x. Cotangent is cosine over sine. So we have cosine over cosine, those will cancel, leaving me with 1 over sine. And the reciprocal of sine is cosecant. So we showed that the left-hand side of our equation simplifies to equal the right-hand side. Our second example, we have a fraction on the left-hand side that is more complex than the addition we have on the right-hand side, so I'm going to work on the left-hand side. This is one of those examples of splitting up a fraction. You may remember from Algebra 1 something called the butterfly method, depending on how your teacher explained that to you. So I'm going to split this up as 1 over the sine of x plus cosine of x over sine of x. Sine of x, the reciprocal of sine is cosecant, and cosine over sine is cotangent. So again, we simplified our left-hand side to equal the right-hand side. We verified that this identity is true. Our next set of examples, we're going to be focusing on the Pythagorean identities. Those are really useful. You will use them a lot throughout the next week or so as we're simplifying trig expressions, so make sure you get really comfortable with them. Looking at this one, the right-hand side has the fraction, so that's the side that I'm going to work on simplifying. And in the numerator, it reminds me a little bit of the Pythagorean identity we looked at, sine squared plus cosine squared equals 1. So I'm actually going to go off to the left here and write that Pythagorean identity. As a reminder, This expression, sine squared, really means sine of x squared. We just like to shortcut the notation so we don't have those parentheses in there kind of messing things up. All right, so back to our Pythagorean identity, we've got the sine squared plus cosine squared equals 1, but we have 1 minus sine squared. So if I subtract sine squared from both sides of the equal sign, we get an expression that's equal to cosine squared. So going back to my equation, I'm going to replace my numerator with cosine squared. So we have cosine squared over sine of x. And then what I can do is in the numerator, it's really cosine of x times cosine of x. So what we can do now is split this so only one of the cosines is divided by sine. So we have cosine of x times cosine over sine. And cosine over sine is cotangent. So we have cosine of x times the cotangent of x, which equals our left-hand side. We have one final example, both of these with Pythagorean identities. So that first one, tangent squared plus 1, came from the Pythagorean identity tangent squared equals secant squared minus 1. So if we solve this one by adding 1 to both sides, we have tangent squared plus 1 equals secant squared. So we'll replace that first expression with secant squared. Our second expression, very similar to what we just saw on the last page, is sine squared plus cosine squared equals 1. We have cosine squared minus 1. So in order to get that, I'm first going to subtract sine squared from both sides, and then I can subtract 1 from both sides to get our cosine squared minus 1, which will equal the opposite of sine squared. Be careful you don't drop that subtraction sign. It turns into a negative sign. So now we can go back up to our equation, substitute negative sine squared in for our cosine squared minus 1. And I'll use my reciprocal identity with secant squared. Secant squared becomes 1 over cosine squared times the opposite of sine squared. If we want to simplify that and put it as one fraction, we get sine squared over cosine squared. Sine over cosine is tangent, so we have the opposite of tangent squared, which equals what we started with on the right-hand side.